So let's take a look at the agenda today. As you can see, it's a pretty robust agenda, but we're going to have to look at this because sampling has been considered the beam that holds the whole apparatus of research together. So we're going to look at both probability sampling and non-probability sampling, examples of them, and also we will consider some of the challenges associated with sampling that we have to try and minimize, and of course that's part of what we're learning here in this course. So let's begin by looking at some key terms in sampling that you need to be aware of. The first four of these key words are element, population, sample frame, and sample. Now an element is a single case in the population that you're looking at. A population is all the cases, with the total number of cases that you're interested in. A sampling frame is a list of the elements the sample will be selected from, so it's obviously smaller than the population. And a sample will be taken from that sampling frame, and these are the elements that you're actually going to investigate and conduct your research project on. You have to be interested in the representativeness of the sample, and that means a sample will contain the same essential characteristics of the population, and you can actually do this or calculate this. A probability sample and non-probability sample are two different ways of constructing samples. A probability sample is selected using a random process so that each element in the population has a known likelihood of being selected. And a non-probability sample is quite the opposite. It's a sample using a non-random method. We have to be concerned about the two top points here in terms of sampling error and non-response. Sampling error is an estimation of the error that occurs because of differences between the characteristics of the sample and those of the total population. And the other thing that we have to be concerned about is non-response. We're going to get to this a few times in today's lecture. This is when an element selected for the sample does not supply the required data. In a sense, this is just the total number of cases and trying to collect all the data from all the cases possible. So let's look at bias and sampling error as our next topic. There are a few sources of bias in sampling, and one of them is when you're not using a random method to pick the sample. Of course, it's going to be very likely that you are going to have a biased sample. But you also should look at the sampling frame, and sometimes that involves some human judgment, and there's an errors in human judgment when you're trying to select one group over another. And non-response, of course, is something we're concerned about because it's people who fail to answer a question that skews the data. Sampling error are the errors of estimation that occur because there's a discrepancy between the sample group and the total population. It's virtually impossible to eliminate sampling error, and we can use random samples and other things to minimize that, and we can actually calculate sampling error as well. So using random samples and making a sample as large as possible, having a big N, as we've talked about in previous classes, will minimize sampling error. The next couple of slides will look at a couple of different pictures of graphical pictorial representations of sampling. And the top left quadrant shows you a perfect sample, and going to the right of that you can see a little bit of a sampling error. And notice in the bottom right quadrant where the sample has shifted. It's actually quite significant and results in a skewed sample. So pictorially you can sort of look at how sampling error does indeed happen. When we look at sources of error, there's usually four sources of error that we can look at. There is a sampling error that could emerge. There's a sampling. The method also has to be considered. Also, in terms of data collection and data processing, these are two areas where research can be subject to mistakes. We've talked about some of these already. In terms of probability sampling, we're going to have to do a little bit of math here, so bear with me. It's not going to be too difficult. But the first thing that we'll look at is simple random sample. And this is, if I was to do a research project of students in the class, what I would be looking at is conducting a simple random sample. And that means that any student in the class could be asked a question. That could be you, it could be someone sitting right next to you, it could be someone sitting on the opposite of the class. Every element has the probability or the possibility of being selected equally. And we can do that by actually generating a table, a random number table, that allows us to get to that random sample, or we can do it through computer-generated lists, and which is obviously the more popular way of doing so. But how you select that random sample is that you first have to devise a sampling frame, and there's going to be elements in the total population that you want to study, whether that in this class be gender, whether it's a year in the program, whether you're a political science major or not, and so on. Two letters here that you're going to look at. Pick a sample size, which is small n, and total population of big N, and we're going to need those numbers for a calculation that we're going to perform. And this is the calculation, which is the sample ratio. The sampling ratio is little n divided by big N, or sample size divided by total population size. And just to go through the calculation, a sample size of 1,000 taken from a total population of 100,000 leads to a sampling ratio of 0.1, I should say. And this is an important number. It's not the most important number, but sometimes you get asked the question in your research about what the sampling ratio is, and you have to provide an answer to it. So, very easy calculation to make. Just your sample divided by your total population, and you get an answer to the question. There's also other ways of doing probability sampling. One's called a systematic sample. A systematic sample is calculating every if case. So if I was looking at the class and I wanted to calculate every 10th case, what I would be doing is I would say, I'd have you sit down and I would number you from left to right and from front to back. And I would say I'm going to talk to every 10th person. And I'm going to start this at a random start point, which is I'll start at number 9. So I'll choose person number 9, 19, 29, 39, all the way up to the total population, last 9th number. And that's how we can do that by systematic sampling. But there is a problem of that, and sometimes when you're looking at devising a systematic sample, if you're arranging your sample in a particular way, say I wanted to look at fourth year political science students versus third year political science students in class, and you're arranged in a manner that alternatively sits beside a fourth year, sits beside a third year, then a fourth year, then a third year. And if I'm saying, if I pick an even number, there is a quite strong likelihood that I'll only have one of those third year versus fourth year people responding to all the questions. So you have to be very concerned about that. Stratified random sample is a different method that is also interesting, and this is how you try and devise samples between subgroups in the population and how proportionally represented they are in the sample. So assume you're doing a study of students and you want to ensure that each faculty is represented in the sample proportionally, and assume a sampling ratio of 1 in 20 or 0.5. The number of cases drawn from each faculty should equal 1 out of 20 of all students in that faculty. The result is not guaranteed with a simple random sample or systematic sample. So you might want to stratify your sample, and this chart explains how this will work. So if you have a population of students, which is in that column there, you have then produce a ratio of people that you need to examine. The stratified sample will mirror what that total population is. However, if you do a total random sample, the results aren't going to be as evenly distributed by faculty, and that's why you would conduct a stratified sample, just to get that balance and the adequate number of of cases that you need to look at. Selecting a stratified random sample is an interesting process. You have to stratify the population into subgroups, and as our example stated, we did that in terms of faculty. You select a random sample or a systematic sample from each stratum, so you look at creating something that you can study, and that's done at random or systematically. And you use this procedure to ensure that each stratum faculty is proportionally represented in the total sample, so that you have that ratio there. And this is an interesting way of doing things. Not always a practical way of doing things, but it certainly gets results. And sometimes when you look at voter surveys, for example, when they're trying to predict the likelihood of voting, they're usually stratifying their sample to some degree. Another probability sampling is called multi-stage cluster sampling, and it involves a process by which you want to do multiple clusters. So you're trying to do a sample of the larger cluster and a sample of the subunits as well. This usually happens when you have a large geographical space or a large number of different items that you have to talk about, where you have to piece it down and break it down a whole lot more. It's something that you need to be aware of. Let's take a look at some issues in sampling that you may be aware of or you may not be aware of, but they're important to go over nonetheless. First of all, sample size. In terms of sample size, the absolute number matters the most. Not the ratio, but the number. And as sample size increases, the sampling error tends to decrease. So if we look at some common sample sizes of 100, 400, 900, 1600, 2500, each size increase cuts the sampling error by half, then by 1/3, then by 1/4, and then by 1/5 respectively. So the greatest difference, of course, is that jump between 100 and 400, where half of the sampling error is reduced, and that's pretty impressive. The biggest change occurs between that number, and the question that becomes necessary to ask when you're doing research is, what is the appropriate sample size? And usually there are constraints that are associated with that. The constraints are both time and on how much it's going to cost to sample the number that you want. Non-response is something that we've talked about quite frequently today, and it is certainly something that is of concern. We're talking about sample and sampling. The response rate is the percentage of the sample that participates in the study. And we know through different techniques like phoning and by mail-in surveys and so on. So the response rate tends to be low, and that is certainly a problem. And you have to understand why it's low. There are things that you can do to reduce the non-response rate. For example, you can call back. So if a number doesn't pick up the phone the first time, will you call back, and how many times will you call back? And usually the research methodology of your study will outline how many callbacks there are. You want to make sure that you're reassuring the respective participants about what the information they're providing is going to be used for. If it's a face-to-face interview, for example, you want to make sure that you're not intimidating, that you're dressed appropriately. And ultimately, you want to make sure that you are flexible with your participants. You have to keep in mind that they are taking time out of their busy lives to answer your questions for your research. And sometimes a little incentive can be applied, although some people are neither here nor there on that, just to have people complete the surveys. You might give them a token gift or something of that nature. In terms of the heterogeneity of the population, we're talking about how diverse that population is. And the more clusters or the more characteristics and the more kinds of elements that might exist, the greater the need for a larger sample size, because you want to make sure that in those subgroups you have enough of a sample to actually have statistically significant results. Again, these measures of statistical significance can be derived from statistical programming and so on and so forth. What are the determining factors that you're going to have to consider? The sample size, for example, needs to vary depending on what kind of analysis that you're doing, whether it's a quantitative or qualitative piece. If you're looking at small groups, you might need to oversample some of those smaller grouped people just so you have enough responses to compare to the larger group. And certain statistical procedures, such as multivariate analyses, require large sample sizes to work properly. So let's move on to non-probability sampling. And this is, of course, popular with qualitative research. First, we'll look at convenient sampling, and this occurs when you're looking at cases that are included because they are readily available. So if I'm doing a study and I want to know what people say about X, and I am teaching a class of 100 students who are interested in research methods, I'm going to ask you that, and I'm going to ask you the question simply because you're in front of me and I'm able to ask you. The problem is that you can't necessarily generalize the result to a larger population with any degree of confidence. So you have to use convenient sampling with a grain of salt. And convenient samples are useful in pilot studies or just to test some stuff out to see if you got the gist of your questions right and so on and so forth. Good method for that. Snowballing is a form of convenient sampling that's popular with people who do ethnography and interviews. And this is when a researcher makes contact with some individuals who in turn provide a list of other people. So you go into an interview, you ask, is there anybody else you think I should talk to? And that is obviously filled with bias because the participant might give names of people who think similar to them. So that might not give you the kind of diverse research that you need. Quota sampling is another form, and this is collecting a specific number of cases in each particular category that you're looking for. The difference between this and some of the other forms of probability sampling is that this is not done at random. So if you want to talk to 10 Roman Catholic families and 10 Jewish families and 10 atheist families, you're going to reach those quotas, and once you reach them, you're done. But the selection, of course, is potentially biased because you're looking at people who might be best positioned to give you that feedback. So that's what we talk about, some of those issues that might be present. Quota sampling is typically used in market research studies because you just want to get a sense of what people are feeling, but it's rarely used in social scientific research in North America. And the criticisms, as I've mentioned before, the quota samples are not likely to be representative. The judgments of who is eligible or who might be helpful is subjected to researcher bias, and when you're doing quotas, the tendency is to find people who you think are going to get the most information from and get the research done as quickly as possible. So it's hard to do inferential statistics as a result. However, there are certain strengths to quota sampling that we have to consider. And first of all, it's cheaper, it's easier to manage compared to random sampling. You can get to your quota faster in many ways with surveys completed. It can be conducted much more, as I say, quickly. And again, this is a good technique to use when you're just trying things out and testing out your questions and moving forward in that direction. We also have purposive sampling, and this occurs when the participants are chosen on the basis of a particular characteristics that will help the researcher to explore the research topic. And this might mean specific experiences that the researcher is looking for. It might talk about examining specific social roles. And it may be important that there is diversity, but this is not necessarily nor at times possible. And it all depends on your research study. Problems that can arise is a sample that might be biased, but this is thought to be lessened if the criteria on which participants are selected is properly vetted. Some more things on qualitative sampling. We have to look at data scientists have collected and analyzed. Data collection is determined by whatever theoretical or conceptual issues emerge as the study progresses. And in addition to that, people and contexts may be sampled in qualitative studies that are very unique and very different. And that's why a lot of people like to use some of this qualitative sampling, even though it doesn't provide the confidence of probability sampling. So we have a couple of more sampling techniques that you're going to have to be aware of. One for structured observation, the other for content analysis. In terms of structured observation, these are some key considerations you have to take into account. First of all, there's typically no sampling frame. So if you're doing a study, say in a hospital, and you're looking at exploring people's attitudes in an emergency room, you're usually not going to be able to find a list of people who are admitted to the emergency room a given night. So sometimes what that means is that you're going to use time sampling. You want to be in an emergency room at a particular time throughout the day. Sometimes in the morning, sometimes in the afternoon, sometimes in the evening. You may include place sampling. A study of student activities on campus, for example, may involve a sampling of places such as dining halls, pubs, and classrooms, depending when students are in those areas. And it may include behavioral sampling. This example, this was a researcher might want to observe every fifth interaction between students and librarians at a particular reference desk at a university. The last part we're going to look at is called content analysis sampling, and some considerations that you might want to be aware of. First of all, the media may be sampled, and that obviously has important nuances. Newspaper articles may involve sampling of different newspapers or articles on a given topic, and you want that diversity because journalism can vary between place to place and topic to topic. And you might want to sample dates. For researching media portrayals of anything, you might want to include a random method to select the years in which the media are to be analyzed, and this will give you an appropriate sample of material to look at. These are some things that you just have to take a look at, and certainly with sampling, there's a lot of different techniques, probability, non-probability, and other areas that you have to consider. And this is all done to ensure that we are appropriately giving the confidence to the researcher and those we're doing research for, that the results that we're obtaining are results that have a certain degree of confidence that they reflect what the environment or what the attitudes or whatever it is that we're studying, that it's an accurate portrayal of what's taking place in those moments in time. Well, I hope you enjoyed today's lecture, and if you have any questions or comments, please feel free to ask.